a lot, which I think you'll agree. And we welcome you to tonight's lecture. I'll turn the lecture over to Deborah and our team. Thank you very much.
Thank you, Carol. I'm a past president and museum collection chair, so that sort of ties into the Musket. And I'm going to ask everyone to save questions until the end. We have 5 presenters tonight, so it's a pretty exciting presentation for us. The Musket came to us, BCHS, in 1915 after a boy found it in the mud near the Hackensack River and the Steuben House. The site experienced over 11 engagements in the American Revolution because of its strategic 1744 bridge in front of the Steuben House, for those who haven't been to the site. We recently prioritized conservation of the Charleville musket, as one could see rust on it, for example, and the wood, it was all taking a toll on the object, the artifact. So we, of course, want it to survive for future generations to be able to research it and to experience the artifact. And I'd like to introduce our first presenter, Tom Hand of Americana Corner, founder in 2020.
Right.
Tom is such an amazing person, I think. I mean, for an individual to take the initiative like he has and making important contributions to organizations across the country, he's got to speak a little bit about it, I guess. But for us, it was huge. He gave us a grant to conserve the musket, and I guess it's about a year ago now. And it was just just wonderful. I can't tell you how thrilled I am. So Tom Hand, take it away.
Well, thank you, Deborah. I appreciate that. It's a pleasure to be here. Thank you for including me tonight. I won't talk too long. I just want to tell you about Americana Corner. I started it, as you say, 3 years ago. It's hard to believe it's been 3 years, but time flies. I wanted to remind Americans about this great country in which they live. And Shar and I have been blessed with some financial resources. And so I wanted to do more to kind of give back, I guess. And I started writing stories, inspirational stories about the great American past, and created this website called Americana Corner. And that went over pretty well. And so I thought, like being on camera. And so I thought I'd start doing some videos. And we did some videos corresponding to the weekly post, about 2.5 minutes, nothing too long. People get tired of watching the videos. And so every Tuesday we post a narrative, an inspirational narrative about something in American history. And then I script a script out of that. And then on Friday, we post a 2.5 minute video. And so I thought I was doing some good with that. We're getting 200,000 views on some of our videos. But I felt like I could do even more, because I couldn't be more than one place. But we had resources, financial resources, that we could help people like Bergen County, the boots on the ground, so to speak, present their message and preserve their artifacts. And so I came up with this grant program called Preserving America Grants. I didn't know how it'd go over, because we didn't have any credibility. No one really knew about us. And we started it. We got 63 applications. We gave out 63 grants the first time. And and one of our recipients was Bergen County. And we were so happy to be able to preserve this artifact from the American Revolution. It's a sort of piece that ties the revolution to today, and we have to preserve those sorts of artifacts, in my opinion. And so we moved forward to this year, and this year we actually got 236 applications. We just bowled over by that. We gave out about 133 grants, including, I'm happy to announce, a grant to Bergen County to purchase a display case in which to house the musket. And so hopefully that will happen sometime this year. And so our whole idea is to help early American history organizations like Bergen County do their job. A lot of these smaller organizations are all volunteer. They don't have the resources of a Mount Vernon or Colonial Williamsburg. And so we're hoping that we're helping them in our small way. We have given out 6 grants in 2023 so far to New Jersey organizations. We're happy about that. It's, I think, number 2 in our state list. Pennsylvania's number 1. I think we have 11 up there, but very happy to help out. We hope that this year, Bergen County will apply again for another project, and be happy to help them. We're putting out a book this year, good Lord willing, our first one, kind of a series of compilation of some of the things we've done in the past. And so, yeah, that's the American kind of story. And anyway, thank you for listening. And we'll take some questions at the end of the presentation.
Thanks so much, Tom. That's just fantastic, really. Let me move on to Gary McGowan. Gary has a presentation. Gary, I've known a pretty long time now, going back by 2007, we got hit with the nor'easter, our region. And he's been such a resource for our organization over the years. He's like my go-to when I need advice on collections, restoration or work. I, of course, you know, with the opportunity with the Musket, I turned to him, and I think he took the whole thing apart. I'm not sure what photos he's going to show, but if you could take it away, Gary.
Great. Thank you so much, Deborah. Let's see. Has everybody got it up there
Yes.
on your screen?
Yes, I see.
Fantastic. Great. Good. So let me just get myself oriented here. I might do conservation, but I'm not the greatest tech whiz out there for these types of presentations. So I was contacted by Deborah and BCHS to work on this actually fantastic artifact. It did pose some very difficult conservation issues because the object came out of the river. And let's see, I'm sorry, Deborah, I kind of stole this from you guys. This is
right.
One of your graphs.
Right about number 3, I think. There.
But it's sort of, yeah. So I just wanted to orient everybody that is here tonight listening to the talk, because I'm not sure everyone has been down to the Steuben House or been by the river. So as Deborah had mentioned, the gun was recovered by a young person in 1915, and somewhere in and about the water adjacent to the Steuben House, which, as she'd said, you can see it right there on the graphic. So when an object enters into the archaeological environment, and in this case into the river, it reacts to that environment, and compounds or chemical reactions, deleterious materials start to break down that object. So if we figure that the gun had been in the water for close to 150 years or 150 years before it was recovered, it had been in that environment, reacting to the water, reacting to the chemistry within the archaeological environment. And then here's just a picture of the Hackensack River. And there was fresh water, but silty areas. I'm sure the gun eventually was slightly silted over due to the preservation of the gun. If it was in a very heavily oxygenated area of the river, we would have had less of the material preserved, so less of the object would have survived. So typically when things enter that archaeological environment, and in this case the river, oxygen is depleted as things silt over, And then the object eventually, you can see here's just another shot of the river there and sort of the bank. So it was a very natural environment, but still there are chemical reactions to things within the river. So when oxygen is depleted out of the environment around the object, whether it's in the ground or in the river, in this case, an object reaches a state called equilibrium, which means that it is deteriorating, but rather slowly. And it reaches this point of sort of symbiotic involvement with the chemistry and the physical attributes of the burial, whether it's terrestrial or in the water, as it was with this case. So things tend to slow down, the processes of deterioration slow or sometimes halt. And that's why obviously objects can survive for thousands of years in an archaeological environment. So as deterioration slowed, and this is just a picture, has really nothing to do with the gun, but I just wanted to show you as things sort of are either enter the archaeological environment or are buried, silted over, then the object kind of survives for a long period of time. So this is just a little off to the left-hand side, a little bit of iron of an object kind of going through that state of reaching equilibrium and reacting to its environment. So as the gun sort of settled in for a long 150 plus years in the water there, it reached that point of stability. And then once it was excavated or recovered, let's say, in 1915, then some of those processes start up again. So when you have an object like the gun that's recovered, oxygen immediately rushes in and starts to attack the iron again, changes in temperature, bouts of high humidity and low humidity also will start this time clock again. So things start to deteriorate. And that's where we were at a year ago, where things had been steadily ticking up with its deterioration. And you could notice active corrosion, and you could see small bits of the metal exfoliating from the surface. So it was clearly time, and we were really fortunate, wonderful to get the grant money to deal with the conservation and stabilization of the gun. So I'm just showing you the full rifle, both sides. You see the lock plate and the firing mechanism, and then on the right slide, it's just the opposite side where you would see what would be a lock plate, which is missing. And I'll sort of discuss that further as I go through some of the photos. But again, in fairly good condition for its age and what it went through of being wet and waterlogged for a long period of time, and then coming out of the water and being curated in a building or a museum before the BCHS received the gun and so on. So it's been through a lot. And one of the things that was of main concern was to stabilize the gun to prevent any further deterioration. So as a conservator, we're not restoring the gun. I'm not trying to bring it back to its original appearance. I'm trying to halt those agents of deterioration and stop the loss of the material that we currently have as an archaeological object. This is the end of the barrel, and you can see that we have loss of material, which I am not an expert in guns from a historical standpoint, but I am told that a lot of the information that would fully identify aspects of the gun could be found at the end at the barrel, and unfortunately with the deterioration that's gone. So Again, I'm sure there are other people that are speaking tonight that can maybe talk to that aspect of what's been lost. But you can see in this rust, this bright orange, that's active corrosion. And at the top, you see a close up, that's the wooden part of the gun and the barrel that's set into it. So the complications of an object like this is you have organic materials being the wood, and you have inorganic materials being the steel or the iron for those components, and they don't play well through time. The conditions that preserve wood are relatively moderate humidity of 50%, and a temperature range of 70, 75 degrees for its long-term preservation. Well, the actual metal components really require a much lower humidity in a museum situation or in a storage or curation of the gun. So they're already playing at odds with each other. So as part of our conservation effort, we're going to try, or we did, compensate for those two discrete materials and try to stabilize the gun so that it's not going to react in the environment, and that it will be a little bit more forgiving with the temperature and humidity ranges that an institution can provide for the gun. So it's a very complicated situation. There again, here's just another close-up showing a hole in the barrel. And I know some of the other speakers later tonight will be showing you images of x-rays and sort of 3D modeling of the gun. That was really critical in giving me guidance as I started or carried out my conservation, because I'm not really sure until I have some of that instrumentation done, density of the material, if I can clean it, how can I handle the discrete objects, whether it's the steel or the wood. And when I'm working on an object that's complicated like this, I try to get as much background information as you possibly can, and x-raying the gun was just critical to understanding the structure and at what point we could carry out different treatments without doing any damage or impacting the material that's left. We also, on a side, were trying to see if it was still loaded and if there was a ball in it, because the gun was cocked, but there was no ball inside, and there was nothing inside the gun that we saw in the x-ray, but it did help guide my conservation treatment. There's just a side view. You can see the barrel, and then you can see the wood stock below. That little fuzzy kind of white appearance is actually salts. Even though this was a freshwater site that the gun was recovered from, plant materials and other organic materials breaking down can produce salts, and they enter into the structure of the iron or steel. And as they fluoresce or effloresce on the surface, they can cause damage to the metal. So that's what you're seeing, these sort of dappled surface. You sort of see that blackish brown reduced surface, and then the orange of active corrosion, and then the sort of white fuzzy materials, which tend to be salts. This is just another close-up showing how deteriorated one of the little screws are to for this fastener here. So we had, again, some areas that were very, very fragile. Other areas, the metal was fairly robust. When an object like this enters the archaeological environment, as it's deteriorating, some of the surface of the metal is actually lost in the form of corrosion. And then a reaction can occur within the burial context where it replates onto the surface. So you get these kind of concretions of material or metal ions or corrosion reforming on the surface. So you lose detail, you lose some of the morphology of the structure. And part of my task was to clean and try to remove some of these concretions on the surface. But again, the X-ray or the series of X-rays really helped me to determine where the original surface was and where the original metal may be. So when I'm starting my cleaning process, I know that I can remove certain parts of the corrosion, but not be as aggressive in certain areas where the metal has either been compromised or completely lost. You can see again, there's where a screw was originally, but has been lost through degradation of the rifle. Some of that orangey brown corrosion is that layer between the wood and the barrel. And again, some of these concretions on the wood of salts and other materials that were absorbed by the wood and have then through time sort of migrated out to the surface as the gun dried and has been at BCHS for a while. There's just another shot of again, active corrosion. Because this hadn't been treated in quite a while, there was this cyclical reaction to the environment. And so corrosion would start up, slow down as the winter months would, the humidity would drop, temperature would drop a little bit, and corrosion would slow. And as soon as then the environment, summer months in August per se, this corrosion would reactivate because the metal was very highly reactive to its environment at this point. Most archaeological pieces, once they're recovered from their burial sites, are highly reactive. This is a close-up. At some point, the gun, as it was curated, I think Deborah could answer this question later on, but I think that they actually tied the wire around it because it was literally coming apart. The wooden gun stock was actually cracked in several places and could no longer structurally support itself. The lock here was heavily corroded, and the metal quite embrittled and deteriorated.
Yeah.
You can see at the bottom there where there's that sort of long slot that would have had the trigger. And so when I started working on the piece, a lot of the gun parts were not properly oriented because they had just deteriorated after all that time, both being in the water and then subsequently on land and drying out. So I came to the conclusion pretty quickly that the only way to really treat this object was to break it down into its discrete components, because they needed to be treated separately. What treatments needed to be carried out on the wood were quite different than how I needed to treat the metal. Plus, I needed to get to the interior of the metal inside components to stabilize them and to stop further corrosion. So with a little bit of finger crossing and a short prayer, I began dismantling the gun. There's just another side. I do want to point out to you, because I think it's a very important thing to mention, and I think maybe as some of the other speakers tonight will sort of go through descriptions of the gun what an actual gun of this type would be like, and what was preserved archaeologically and what was not. So on this side of the gun, there would have been a lock plate that would have held the mechanism, and a screw would have gone through that hole where the wire is sort of wrapped around and holding the pieces together. So there would have been a screw that went straight through and lined up with the lock mechanism on the other side and screwed it all together. So that's missing, and the lock plate itself is missing. I sort of thought about this for quite some time, and was thinking, well, is this deterioration? Have these pieces been lost just from the archaeological environment? But that didn't really make much sense when some of the other pieces are in fairly good shape. The other large screw that's across the top, its threads are still crisp. So it made me feel that this gun may have had parts removed or salvaged from this gun before it entered into the river. And I think one of the pieces that was removed from this gun was the lock plate and this screw. Now, I can't say why, but I do believe that this is evidence of dismantling some components of the gun prior to entering that river. The lock plate was removed, the trigger itself is missing, and the metal butt plate on the back of the stock is also missing. However, there are screws, and I will show you in some other photos. There are remnants of the screw. So I kind of feel like you know, this was more or less salvaged or pieces removed, maybe to be used on another gun or melted down. I don't know. But here's the bottom view of the gun, and you can see where that's been cut out, and that trigger guard and or where the trigger assembly would fit is missing. So again, I think this is sort of removed prior to entering the river. There's the back end. You can see the screws by where that white, where the labeling is, but you see a hole there and a screw at the top that would have been used to affix the metal plate at the back end of the gun, which is missing. Since the preservation of the screws is fairly good, it leads me again to believe that that piece was removed. But there is a very long horizontal crack that runs down the butt end of the gun. And that was something that I had to deal with and compensate for to stabilize the wood component. I believe it is black walnut, as the sample of the wood that I looked under the microscope. I'm pretty confident that it's walnut. There's just another shot of it. The wood was quite brittle and stained from the river, and then subsequent 100 years, more or less, that it has been out of the river and curated. There's that screw at the top. You get a close-up view of the wood. There's even a little bit of efflorescence of salt within the wood itself that was absorbed while it was in the river. As I started to dismantle the gun for treatment, this is just now the lock assembly flipped over, and you're seeing the interior structure. You can see all this sort of powdery, rusty orange color where the metal has been consumed. It's no longer solid metal, it's just oxidation and corrosion. We started mechanically cleaning some of this material out of the different components. to try to bring back the structure and to stabilize the metal. This is also that large screw you saw in the previous picture where you saw it from the flip side, but this is just me dismantling, removing that exterior wire that was placed on it to support the gun. And as we're dismantling the piece, this is where it was helpful with x-rays to see how things were joined or affixed, or if indeed there was a ball still in the barrel. There's the interior where we've done some cleaning. We've removed some of the material in pretty good shape, I have to say. There's just another view. That large opening there at the middle of the piece, that would have been corresponding to the screw that is missing from the lock plate. So because that's in such good shape and it still has some thread lines on it, I do believe that that piece was removed before it entered the river. So I just show you this schematic. As part of my conservation treatment, we dismantled the gun into its discrete components. And then if you see at the very top left-hand side, that's just a little graphic showing an object. In that case, it's a nail. But what we carried out was electrolytic reduction. And this is a method in conservation that's been used, oh my goodness, for many, many years. In the 1940s and 50s, conservators were using this technique, which is still valid and still works quite well. But we took the metal components and they are suspended into a tank with an electrolyte, which is can be a variety of things. Can be calcium carbonate, could be sodium hydroxide. It's a material that will allow an electrical current to pass through the 2 points of an anode and a cathode and through to the object. And what this does is it will remove corrosion. So a lot of that oxidation, corrosion, rust on the surface will actually leave the object and plate onto a sacrificial piece of metal that's within this tank. The other added benefit of electrolytic reduction is to actually purge the object of some of these salts and other deleterious compounds that will react with that electrical current being passed through the object. So we desalinated and removed some of those materials at the same time as removing the corrosion. And once we carried out electrolytic reduction, we managed to gain back some of the morphology or some of the structure of the metal was cleaned up. So visually you could see the components better. They were stable at that point and were no longer reactive. So this was a good tried and true method for dealing with materials like that. Now, I didn't put the wood back into something like that. The wood was cleaned. Some of the areas were poulticed, which means I put something like cotton or another material down and actually draw using a variety of wet materials with maybe a detergent or with alcohol and water, and draw out some of the surface debris and material into that cotton or material on the surface to pull it out, to poultice out the materials. So we did that on the wood. We also had to repair structurally the wooden components because as you saw in previous slides, the two pieces were broken right at the lock plate, so that the gun stock was broken in two, and there was a very long horizontal crack that ran right to the end of the gun. All of that had to be clamped and rebuilt using some conservation adhesive and fill material to bridge the areas of loss so that we could reorient the gun to its proper position and then reinstall the metal components. So this is, unfortunately, I have it sideways, but this is after the electrolytic reduction where the surface has been reduced. That's why you sort of have this darkened appearance. Keep in mind that originally the gun would have had more surface, which would have been that sort of shiny, metallic, silvery look. There's been a lot of loss to the original surface, the original structure, and you're left with this reduced metal surface. We've rebuilt the missing components to the wooden stock and reoriented where the trigger would have been if it had survived, and added some structural supports on the interior of the gun, which visually you won't be able to see because it's all internal work. That's just another shot. You can kind of see the plate where the trigger at the top far left. We made a decision not to reintroduce any reproduction components if we could avoid it. I did put back a piece of metal for the lock plate on the opposite side of what this image is showing you. And I just did that because we needed some structure on the other side to hold everything together when I was reorienting the wooden components and also reinstalling the lock. So for the most part, we didn't add anything to the gun. And in conservation, we try to use materials and methodologies that are reversible. So we didn't want to introduce anything that we couldn't undo. So our adhesives and other techniques can be undone. And certainly the reproduction lock plate could be removed at any point for further study of the gun, or if BCHS chose to do some different reproduction component that I didn't fabricate. So there you go, there's the bottom. There's the crack once it's now been consolidated. We had to utilize a acrylic consolidant, which again is reversible. It's a material called acryloid B72, and it's an acrylic that goes into the wood and is absorbed into the structure of the wood, and that's not typically needed, but the wood being in that wet, waterlogged environment for such a long time and then coming out and drying, it was quite brittle and showing deterioration across the whole structure. So we decided to introduce an acrylic to preserve the surface. It's just another shot. And my last shot is just, you can see that we've reduced heavily a lot of the corrosion and removed what we could and tried to bring back and reclaim some of the morphology and structure of the gun. So that's about it. That's just it and its mount. I'm sorry I don't have a full image of it completely conserved, but for those that haven't seen it, I would highly recommend making a trip to BCHS and you can see it on view.
Thank you,
So
Gary.
Thank you.
Yeah. So if we had not done the conservation work, the object would have continued to be compromised, the metal and the wood.
Most definitely, yes.
Okay. All right. Well, we're going to continue on here. That's really, I did not know that much, so that was great, that information, Gary. We have Patrick Ibrahim, who is from Picatinny Arsenal, and I was so glad to be able to connect with Picatinny. I'm sorry I didn't make it to the labs, but I know Gary did, and the images are fantastic that Patrick is going to share with us now. If he's there, there he is.
Great, thank you so much. Yeah, again, I work for the radiography lab at Picatinny Arsenal. We have multiple capabilities for X-ray and CAT scans, computer tomography scans, where we can reconstruct items and put them in 3D models. We work with all sorts of different items for the Army. We work on artillery shells, mortars, grenades, and every now and then we get cool items such as the musket, which for me, it was probably the coolest item that I've worked with during my time in the lab. So I'm going to share my screen. And hopefully you're able to see my screen right
Yes,
now.
we can see it.
All right, so this right here is the 3D model of the musket, where we can manipulate it in 3 dimensions. We can also slice through it in any directions. And when scanning the musket, there was a couple of challenges that we had to deal with. The first was the massive size of the musket. Our detectors are 16-inch by 16-inch, and our systems, the X-ray source and the detector, they don't move. If you go to a doctor's office and you get a CAT scan, they usually sit you down on a table, they tell you not to move, and the system rotates around you. For us, since we work with items that don't move, the table moves around and the system is stationary. So the work around that was we utilized foam from that you can buy from Home Depot or Lowe's, just your insulation foam. And we like that because it's low dense. So when we scan it, you can't really see it in the scan and the item looks nice, like right here and suspended. The second thing that we had to deal with was the fact that there's wood in the material. X-rays, they usually don't like wood and it scatters off of wood because of how many layers there are to it. So it can cause scatter in the image, which could make the CT not look as nice. But we tried a couple of different techniques and we were lucky to have this final product. So from the outside of the item over here, you can see the holes in the barrels that Gary was talking about. We can see some of the cracks since our resolution for the scan was about 132 microns, which is about, I want to say 5.2 thousandths of an inch, which came in handy to be able to see any fine cracks in the steel and in the wood. We can slice through the musket and keep going back and forth, both in side view and from a top-down view, and be able to look at it as if you're slicing through a cake without having to disassemble it. So I'm going to share some of the screenshots that we have. So here's a top-down view screenshot looking down the barrel, and on the bottom left, you can see this crack in the steel. It's a fine crack. I don't have the measurement of it right now, but it's something that we noticed, and we shared all of that with Gary before he started working on it and disassembling it. From a side view in the assembly, we were able to see a crack in the spring, which, who knows, maybe that could be the reason why it was thrown in the river in the first place. Maybe it wasn't functioning and they were like, yeah, let's throw it away. That's just pure theory. I have no idea, obviously. But yeah, so it's a cool shot. You can see all the metal, which is the high density, the bright stuff, and the low dense would be the darker stuff. Here's another shot of the barrel. There's a lot of debris in the bottom of the barrel. We unfortunately we didn't see a ball stuck in there. There's a story in my lab before my time where we were scanning a cannon and we found a ball stuck in the cannon that nobody knew about, which is kind of cool. We were hoping to see something at the bottom of the barrel, but that wasn't the case here. And you can also see the cracks in the wood that Gary was fixing up with the epoxy and the glue that he was working with. Here's another shot of the whole musket, the whole 3D model on the left and a cross section on the right side. And down here in the wood, you can see how it's streaking because of how many layers the wood are. And again, luckily we didn't get too much scatter from that. Here's a close-up of the inside of the barrel. And again, we're not sure what this debris could be. It could be some of the corroded metal that fell in deep down, or it could be just stuff from the lake that washed into it. Sorry, the river. We're not quite sure. And this is a top-down view of that debris. And again, you can see how huge these cracks were on the wood, and it speaks to how good of a job Gary did putting the whole thing together. And here's a little video just of the musket rotating. And in our software, we're able to get rid of the low density material, which in this case is the wood, and we're left with just the metal and the steel, which is kind of cool just to focus on that without the rest of the items. And then here's a short video slicing through, focusing on the assembly area. You can see that crack in the spring again, the debris, the cracks in the wood. And yeah, that's kind of all I have to share. Over.
Wow. Wow. That's amazing. Yeah, from what I understand, where that spring broke, that the gun would no longer be functional. So that I guess would make it no longer useful to be carrying around. So
I
but
don't want to interject too early, but you're right on the money. That's what's called the firing spring. And as you're going to find out when I present in a little bit, it is a major design flaw.
Yeah. But, you know, maybe we can talk about it later. It's just very interesting to put these pieces together, though. And so thank you very much for that X-ray information. That it's really neat to see that.
Yeah,
I think
you're very welcome.
I have that video. I think you or Gary sent it to me also, but it's great to have it explained anyway. Yeah, I can't tell you how much we appreciate that connection. It's just really neat. Also, we have Jeff Renew from Picatinny, and we were able to actually meet Jeff. He also came to the unveiling of the musket in November of last year when we first got it back conserved. And Jeff is a historian at the Armaments Center at Picatinny. And he's also an engineer of Picatinny for 24 years and continues in that capacity in addition to being the historian for the Armaments Center. So Jeff, are you ready? You have a presentation, I believe.
Yes, I just want to say thank you very much for the opportunity to do this, and to Gary and to Patrick. I was thrilled that we were able to help out with this. And I'm going to give a little talk here about Picatinny Arsenal's history and its connection to the American Revolution. Now, while Picatinny was founded as a government installation in 1880 as a storage depot, we became an arsenal in 1907 when our manufacturing mission and our research and development mission started. But there's been some form of military engineering and ordnance engineering and manufacturing going on the site back to the American Revolution. On the site that's now Picatinny Arsenal, there was a portion of the Faish Iron Works. There were 3 bloomery forges in operation there. It was founded in 1749 by Jonathan Osborne. Then Colonel Jacob Ford of the Morris County Militia, he purchased it and he owned it. Mr. Faish leased it from Colonel Ford until 1772 when he bought the property, and the 3 forges and furnace were in operation, for on the grounds of now Picatinny Arsenal. Now, what did they make there? Now, these bloomery forges, they used basically a 400+ pound water-driven hammer to hammer the impurities out of heated iron. Now, what you're looking at here on the screen is an iron bar that was found on the arsenal by our archaeologist, Jason Huggan. The bar itself was about 150 pounds. It's typical of what would have been produced at the Middle Forge. I mentioned there are 3 forges, Denmark Forge, Middle Forge, and Mount Pleasant Forge. Denmark being the northernmost, Middle Forge being right around Lake Picatinny, would have been Clifford's Pond back then, central to the arsenal, the geography of the arsenal. And the Mount Pleasant Forge would have been right around where the road into Picatinny meets Route 15. Now, Faish and his ironworks, they were making primarily these iron bars, common and machine bar at the Middle Forge. They also made iron for tires and wagon wheels, shovels, axes, and things like that. But we do know that they were making shot and cannonballs and things of that nature at the furnace, which is basically just outside the Mount Hope gate of the arsenal. By 1779, Faish produced about 2,612-pound shot, 1,003-pound shots, 504-pound shots, and 5 tons of grape shot. Can do a lot of damage. These are a few items that were actually recovered at Picatinny. On the left, you can see a 12-pounder, 4.5-inch shell. Thankfully, it wasn't loaded with anything. It was hollow. It was manufactured in 1777 at the Middle Forge and was recovered in 1921 during road construction on the arsenal. When you dig at Picatinny, you don't know how much history you're going to find. You'll find things like this quite often. It's currently in the Ordnance Museum of Fort Lee if anybody ever wants to visit it. It was in our museum until 2002 when it was shut down. On the right-hand side here, you can see a photo of a ceramic. It looks like a ceramic wiffle ball, but it's actually an incendiary grenade. Now, it was made out of clay. It was found, again, during some construction around Lake Picatinny. They found, according to the story, a few hundred of these. Now, we have a few in our archive, and some are down in Fort Lee, Virginia now in the Ordnance Museum there. We think what they were doing was they were forming the ceramic down around the lake, and then sending it up to the furnace, Faish's furnace, to be fired, glazed and waterproofed. And what they would have done is, loaded these up with a powder, inserted a wick inside the holes there, and a copper wire with a leather strap. Grenadier would have dropped that down into a bowl full of hot coals to get it going, whip it around, and then throw it at whatever object they wanted to set on fire. The ceramic would crack open and ignite the powder, creating a fireball, and the object being to set fire to whatever it came in contact with. Now, what you're looking at here is a monument in front of what was our administration building. The monument was made up of the remnants of the Middle Forge. So what you're looking at here is the remnant of the hammer and some of the tools that were actually found in the ground in 1880 when the government bought the property and started building. So they had the presence of mind to hold on to the forge remnants and make a monument out of it. Traditionally had been across the street from its current location, but then when we got a new administration building, they moved the flagpole away and set the monument up where the flagpole was. Here's a photo of, on the left-hand side, the remnant of the Denmark Forge. Now, this was the northernmost forge. This is in 1943. The foundations are still there, but the wall has since fallen apart. But the remnant, was still visible as of 1943. Right-hand photo here is of some slag, iron ore slag that was found on the property by a security guard in 1968. He was just doing his usual patrol, walking around, and and came across this and said, this might be important. So he turned it over to our museum, and it was housed there until 2002.
Hmm.
Now, there were legends. Now, we do have a burial site on the grounds of now Picatinny that we didn't actually realize that was there until Picatinny acquired the property in 1944. But local legend states that there were Hessians buried there, and it was a Hessian cemetery. But that's not the case. There was local families used this as their burial ground, and it was the people who worked for Faish. Now, where did this story come from that there are Hessians buried there? Well, we do know that there were prisoners of war, Hessian prisoners of war from the Battle of Trenton that were transferred and made to work for Faish at the forges to keep them running. We know that there were jobs that they did. It was wood choppers, there were 2 carpenters, 2 masons, 2 blacksmiths, a barber, and the all-important beer brewer. Got to have a beer brewer. But in a letter that we do have a copy of, 50 men were exempted from combat duty from the militia to help keep the forges running, to produce items for the Continental Army. So no Hessians actually buried in the cemetery, but we do know of 3 Revolutionary War veterans that are buried there. Now, when we call the burial area the Walton burial, it carries the name of a family that was one of the property owners that now makes up Picatinny. When Picatinny acquired the property in 1944, the only headstones that were still legible were from the Walton family. And there's a girl named Susan Walton who passed away when she was 16 years old. Her gravestone is still on post. You can still read it. But we do know that families such as the Wiggins family, the Burwell family, the Dolan family, that they are buried there, unfortunately can't read the grave markers anymore. But my predecessor, Dr. Patrick Owens, and Kevin Perry, who was an employee at Picatinny Arsenal, did some extensive research to prove that 3 of these veterans are in fact buried on the site, and the Veterans Administration has granted us these 3 grave markers for these 3 Revolutionary War veterans. John Burwell was with the 4th Continental Light Dragoons. Jonathan Wiggins was a wagon master with the New Jersey Militia, and Peter Dolan was a private in the New Jersey Militia. Now, Jonathan Wiggins' grandson, Ewell Wiggins, was one of the property owners that we purchased some of the land that makes up Picatinny from, and we're still using his house as guest quarters for guests to Picatinny Arsenal. Peter Dolan, his home was also used as housing for military up until I think it was maybe only 5 years ago. But unfortunately, the structure, even though it's the oldest structure on the arsenal, it's been modified so many times over the course of its history that it's not eligible for historic protections. A little bit about John Burwell. We have here a record of, well, not necessarily his enlistment, but the fact that he reported for roll call in September of 1778 with the 4th Regiment Light Dragoons. He signed up on 29 April 1777 for the duration of the war. He was the captain in David Hopkins' troop, and he was a private. We do know also that as of November, he was listed on the casualty list and no longer with the 4th Dragoons. There are some legends and stories locally about a one-armed cavalryman working for Faish that it's been attributed mostly to Mr. Wiggins, but we're thinking that in light of this discovery that it may actually have been John Burwell, who lost an arm as a dragoon. And so what happened? What happened to these the forges after the war? Well, Faish continued to operate them until his death. But what we see here, this is actually a letter from Faish to President Washington. It's a character recommendation for David Ford for when he wanted to be the director of the U.S. Mint. So he was looking for a character, someone to vouch for his character, so that he could then be director of the U.S. Mint. He did not get the position, but Mr. Faish did what he could to get him the position. So what we've got here is it from our archives is an original survey map of the breakup of the Faish property after Mr. Faish's death. You can see some of the names that I mentioned, Burwell, Dolan, on these maps. The middle forge tract that makes up the central part of Picatinny now was bought from a man named George Ryder, and he died in 1913 after the sale of it, and he's actually buried in Parsippany right now. So, like I said, in 1880, Picatinny became a federal installation. It's a Lenape word, which means the rugged cliff by the water being Lake Picatinny, which is right at the middle forge, and there's a rugged cliff overlooking that lake. And that's pretty much all I've got here. Just Picatinny's ties to this country go back to its beginning, and we've been doing some form of ordnance engineering and military engineering from day one. And we continue to progress with the times, and we continue to do our research and development mission. And but we always remember what our roots are and pay homage to it where we can, respectfully.
Wow.
Thank you.
Thank you, Jeff.
You're welcome. My pleasure.
It's funny. If you could stop sharing, I could just show. It's funny the tie-in. Kevin, my late husband, historian Kevin Wright, historian at Historic New Bridge Landing, wrote about Andover Ironworks, and he does mention John Jacob Faish. There's references 3 times in the book, so I'll have to send you a copy of that.
I would love that.
It's Andover and Ironworks in Sussex County. So, wow, thank you. And then last we end with Will Krakauer, who's a resource interpretive specialist with the New Jersey DEP in the Park Service out of Princeton. And he's going to be talking about muskets and Charlevilles, I think, in particular in the American Revolution.
Indeed. Let me pull this up. There you go. Can everyone hear me? Good.
Yep. Very good.
So I'm going to talk fairly specifically about the Charleville musket as it relates to the artifact, which is now on display at Bergen County Historical Society. I'll give a little bit of the historic background to the firearm, and then a little more in depth of how it was used during the American Revolution and how it's relevant to our history, even beyond that. Let's see. How do I move this slide? There you go. So you have 3 models of the what will become known as the Charleville musket, which are used during the American Revolution. The first is the model 1763. The second is the model 1766. These 2 models are the 2 that will be mostly used by Continental soldiers, American soldiers during the war. The last one you see down there is the model 1777. And if you're looking at some of the little details I added there about the lengths of their barrels, their weight, and I was able to dig up some rough estimates for the number of these weapons produced over the course of its lifetime as an arm for the French military. You'll see that there are about just under 100,000 of the 63s produced. These are produced immediately at the end of the French and Indian War, and so they had a considerable excess of these at the time of the American Revolution. The 66 model, they produced almost 150,000 of them. And so again, they were readily available. But in 1777, which as we'll get to is right about when the French enter the war, the French troops during the American Revolutionary conflict are going to be using the 77 model. But if you look down there, you'll see that there are more than 7 million model 1777 Charlevilles produced. Now, it's highly unlikely that the one retrieved from the Hackensack River is a 77. Again, because there are pieces of it missing, because the lock plate has been ground down so severely, it is difficult to determine which of these three it might be, but I would say fairly confidently that it's not the 77, who will see most action during the Napoleonic Wars. But there were Model 77s used by the French infantry here during the American Revolution. There are 4 major arms manufactories in France, which are producing what will become known as the Charlevilles. You'll notice that Charleville is only one of the first ones, very much like how we call all of the German soldiers who were used as auxiliaries by the British Hessians, even though not all of them came from Hessen-Kassel and Hessen-Hanau. We colloquially called every gun that was shipped to us from France a Charleville, even if they were manufactured somewhere else. So I pointed out on the map, you have the Charleville manufactory, the Tulle, the Saint Etienne, and the Maubeuge arsenal, both in the south of France, just to give you an idea of where these weapons were coming from. The Charleville is France's first attempt to standardize what we would consider a military-grade weapon. It was started in 1717 and will work its way well into the 19th century. And here is my favorite character of the American Revolution, a gentleman by the name of Pierre-Augustin Caron de Beaumarchais, the Comte de Vergennes. I've listed some of his jobs and pastimes there. You can take a look and see how busy this guy was. Of course, he was not only an ally to the Americans in the early days of our revolution, he was also a playwright, so I've written some of his greatest hits down there below as well. The Barber of Seville and The Marriage of Figaro, which not too long after they were written are going to be picked up by a young buck named Mozart and turned into some very famous operas. Beaumarchais, the Comte de Vergennes, is integral in sort of the early days of the American Revolution as far as providing what we would consider military-grade firearms to a continental army. There is no American military-industrial complex at the beginning of the American Revolution. Most of the arms that are being brought into the field were smoothbore Fowlers or leftovers from the French and Indian War and rifles. And so there is great need of these firearms in great numbers. Vergennes is one of the individuals who try and help in the early days of the war, before the French alliance, to get these weapons to the Continental Army, a small arms crisis forming at the very beginning of the war. We have, I just added a little case study here, the Amphitrite, which is a small packet that Vergennes was using to smuggle goods into the continental United States during the early days of the war. You've got here what he lists as everything that is supposed to come on the Amphitrite, and indeed all of it does arrive, slightly a little worse for wear. The powder was wet, and some of the tents and other materiel was damaged, but you'll see there that among the many things that they are sending over is just over 6,000 stand of arms. This is, of course, crucially important for the Continental Army. However, when these arms come over, more than 50% of those musket locks failed when their firing springs broke. So this is what we were talking about a little while ago with Patrick, that firing spring is broken. So there's here as a direct line to something rather serendipitously with this Charleville. Firing spring broken on the interior of the lock plate. makes it so that this gun is not worth firing. In addition to that, just in the case of the Amphitrite, most of the guns, in fact, weren't even Charlevilles. They were old and cheaply made trade guns, something closer to a fowling musket than an actual military grade weapon like the Charleville. So these are not terribly useful, although, as we will see, our American ingenuity always comes in handy as far as getting these weapons to work for their intended purpose. I added in here a small section of a letter from John Hancock, who is president of the Continental Congress at the time, to General Washington in early March of '76. This is before the Amphitrite will make its run to Portsmouth, but it is on the same line that we're having difficulty acquiring these firearms. John Hancock is of the opinion that there are a great number of gunsmiths in colonial North America who would be capable of creating these weapons. Washington's response is, okay, how many, how fast, and the most crucial question, how much is it going to cost? So the Continental Congress faces this small arms crisis, and they really have two options. They can produce the muskets themselves or fix the muskets that are bought and brought here in poor condition, which you can see I've listed a couple of pros and cons for both, or they can just buy the muskets outright. So, right, you have pros of doing it in-house is our own self-sufficiency. We won't have to rely on anybody to make those muskets. We can contract independently with gunsmiths in North America. The problem is those weapons are expensive. Contract work is expensive. We are currently a war zone. We can talk about how many times these arsenals and laboratories are attacked by British scouts, like French Creek, which is just on the other side of Philadelphia, is burned several times during the war. And there's no standardization of these firearms, which is adding to a logistical crisis that's making it difficult to acquire the correct caliber sized shot for all of these small arms. The pros of buying these muskets were that they were ready made. They could be bought in large quantities, but we had trouble getting them through the British blockade, and they were equally expensive. And as the Amphitrite affair shows, that they come to us with an uncertain quality. In the most American way possible, the Continental Congress doubles down and decides to do both. And so you come out with two leading what we would consider military-grade firearm muskets. The first is the Committee of Safety musket. And I love the Committee of Safety muskets. No two of them look alike. I jokingly call them Frankenstein guns. They are sort of cobbled together with pieces of other parts. So again, nice tie-in with our Committee of Safety with the broken firing spring. We mentioned earlier, Gary mentioned earlier, that there were pieces of this that were likely taken off before it was discarded in the river. These pieces are collected and put on different guns, different stocks, different barrels, different lock plates make up these Committees of Safety muskets. So the one I have here is sort of give you a nice close-up of the lock plate there. You can maybe make out just to the left of the hammer there. It says Dublin Castle. That is a Brown Bess lock plate on the stock of a Charleville with a Charleville's barrel. Like I said, these are Frankenstein guns. They're sort of being put together by local gunsmiths in an interesting way. Here's another example. That's a Brown Bess stock with a custom fit lock plate there. That does suspiciously look like a Charleville plate, but I was unable to confirm that myself. So these contract muskets are going to come in handy. They're being done by private gunsmiths. The states are contracting them independently and getting these orders fixed. The Continental Congress, or rather the Continental Army, is going to these gunsmiths and having them repair firearms that are broken or are coming to the Army broken. And then we are getting the Charlevilles, which are slowly by 76 and 77 starting to make their way into the Continental Army. So you have a nice close-up example here of what a 1763 model Charleville will look like. I like this one. This one is from the Smithsonian Museum down in DC. You can see it's very clearly stamped on the back end of the lock plate, US, and on the center of the lock plate, you can see it's got the patented Charleville stamp from when it was manufactured back in France. Here is the 1766 model, minor variations, difficult again to see, but there's no US stamp, but there is still faintly, you can see it says Charleville on the lock plate. By 1778, we are no longer needing to smuggle the guns in. The French have officially joined an alliance with the Continental Congress. The United States and the French are on the same side, and now we can openly and willingly be sending these weapons to each other. There's no reason to go through gentlemen like the Comte de Vergennes. There's no reason for secrecy. We can outright send these weapons in huge quantities. And so very quickly, the Charleville is going to become the weapon of choice for the Continental Army. So why the Charleville? The standardization of one kind of firearm helps with military logistics. I have a wonderful after-action report here from the Battle of Princeton, which for those of you who don't know is a battle which takes place in early January of 1777. This is the Continental Army during its second establishment. The requisition is for one unit in particular. It is for one battalion of Colonel John Cadwallader's Philadelphia Associator Brigade, and it calls for 13 different sized caliber shot. That is a logistical nightmare that the Continental Army is dealing with at the beginning of the war. With the massive influx of Charlevilles, all the same caliber, all of which are firing the same caliber shot, that logistical nightmare becomes a lot more reasonable to deal with. And so we want the same kind of weaponry. That standardization helps with how smoothly the Army fights and how smoothly the Army runs. Additionally, firing en masse is the traditional military doctrine for the large armies at the end of the 18th century. Certainly, rifles have their place during the American Revolution, but having a core group of infantry armed with the smoothbore musket fighting in that linear style was absolutely critical to winning on the battlefield, on an 18th century battlefield. It played well with cavalry, it played well with artillery. It was a necessary part of fighting. And at the end of the line, of course, there is always, for the Continental Congress, the bottom dollar. It is simply cheaper to purchase a 1763 or 66 Charleville from the French than it was to contract independently within the United States. I wrote there, these are estimates that are recovered by Robert Smith during his in his recent book on manufacturing independence. About $5 colonial dollars to purchase a Charleville, and $12.30 to contract a Committee of Safety musket. So what is our legacy here? You're looking at more than 100,000 Charleville muskets either smuggled or brought to the Continental Army in various stages of disrepair. Over the course of February of 1776 through August of 1781, there's of course 2 more years of war that are unaccounted for in this figure, so we can probably assume that there were more brought than just 100,000. But as I mentioned, once the French alliance is made and more of these Charlevilles are being brought into the Continental Army, it rapidly becomes the most widely used musket for the Continental Army, and that will continue straight through the end of the war and beyond it. We liked the Charleville so much that when our armories opened, the Springfield Armory in Massachusetts models their 1795 Springfield musket directly after the Charleville. So if you'll notice, the first one in particular, the 1795 model, is the exact same specifications of the 1766 model Charleville, and it's a remarkably similar design as far as the concept went. The one I have below it is the last Springfield model that will bear any resemblance to the Charleville, and it's the model 1842, which is chiefly used during the Mexican-American War. However, it is also used to great effect during the American Civil War. So almost 100 years later, the Charleville has an impact on American military armaments. And that's about all I've got for you here.
Mhm. Wow. That's very interesting. Um, I think this whole evening was really a very scholarly presentation, and really learned a lot. I guess our gun could be even earlier than the Rev War version, right? If they were using them in the French and Indian War.
Certainly, it's entirely possible. The models that precede the 1763, definitely there were still some kicking around. I would not be surprised at all if, even the piece that we have has elements of a Charleville, but may have been a committee of safety at some point. Its current state tells us only Charleville. And for that, the identification is correct. From what we can see from the bands on it, it's absolutely a Charleville stock and a Charleville lock plate.
Right. Well, there was a lot of trade going on there at the wharf in front of the Steuben House.
Mhm.
But then again, there were 11 engagements throughout the war at the site because of the bridge. So hard to say, right? But that was very interesting. We can open up the floor to all our participants here. It's very nice you could spend the evening with us. It was a beautiful evening when we started outside. So does anybody have any questions for any of our presenters? I think you have to unmute yourselves.
I have a question for the last gentleman speaking. He mentioned something about the Amphitrite affair, and I can't imagine what the spelling is. I was trying to look that up as we were listening.
Yeah, I'll type it out for you in the chat. It's hold on, Amphitrite, Amphitrite, and it's just a small little New Hampshire ship, two-masted ship that the Comte de Vergennes got his hands on, and they were using it to smuggle goods in. I think it made 2 or 3 successful trips past the British blockade before 1778.
Got it. Thank you.
Or is there anything else from anybody? The musket is on exhibit at the Steuben House. It's in a case, viewable. We are working on preparing drawings and with a fabric cabinet maker, case maker for the new one. So I think we're going to add, or trying to anyway, add lights to the cabinet because of being in the Steuben House. The options for lighting are not so plentiful, and also humidity control for the object that Gary was recommending for going forward for the artifact. So like I said, we are thankful from Americana Corner for the two donations to take care of this artifact. So that'll hopefully, that case will be built before the next retreat event in November. Well, sure, nobody has any questions. It was really fascinating.
I'd just like to thank all our presenters, so much appreciated. Very, very informative, and we value everything that you shared with us.
Mm-hmm. Yes, I guess I can clap.
I'd also like to get in on with what Carol said there. It was a terrific presentation, and I thank all of the experts for their work. And I'd also like to thank Americana Corner for being so generous with us.
Yeah, that was Kate just speaking. She's a trustee and a volunteer coordinator.
Yeah,
And
thank you.
she was
We're just so happy to help. Please remember us, the new application window will be November 15th to December 15th this coming year. Please come up with another creative project for us and spread the word. You want to give out more grants this year. And so if you have people that you know, other organizations, please let them know. We'd love to give out a couple hundred grants this year.
Well, it might take me a week or so, but I'm going to try and post the video on our website, and I'll share it through Facebook and our email blast, which reach we're over 4,000 recipients now. So
Thank you.
all right, well, very quiet. I guess everybody was just blown away. So I guess we can say good night and sweet dreams. Thank you, presenters. If you want to,
There's a hand up, Deborah.
oh, okay, Andrea.
No, CIERO up in the top corner.
Rich.
Richard.
Hi.
Hey,
Sorry.
Richard.
I have a quick question about the, thank you guys. It was absolutely fabulous and fascinating. A quick question about the arsenal. Is that open? Is there a museum there? Is that something that the public can visit? I think it was Jeff who spoke about it.
Yeah, Jeff.
We used to be an open post, but ever since September 11th, we have been closed to the public. Right around the same time, we had a museum until 2002. Center Military History consolidated our museum with several others, so we no longer have an operating museum. That being said, we do tours for civic groups. So if anybody is a member of a civic group or historical society and would like a tour of the arsenal, just reach out and we'll set something up.
Well, maybe we could the historical society could put together a tour. What would that involve? Like where you would tour where the foundries were, or?
Right. We'd go to the various sites where the forges were. We could also go to the burial sites. The Walton Burial Ground. We also go to where the original powder factory would have been, where the officers' housing are, the historical housing, some of our historic sites. We typically maybe like around a 90-minute tour is what we usually do. There was an explosion at Lake Denmark Depot in 1926. We go into a bit of the history of that and how the arsenal recovered from that explosion and the aftermath. So there's a lot of history at Picatinny. So I'd be very, very happy to give a tour.
All right.
That sounds great. Thank you. What a wonderful option.
You're welcome.
Yeah, I'm trying to think of another object to get x-rayed. Have you done cannonballs?
We x-ray all sorts of things. I'm sure Patrick could give a little bit more of a description on that, but as far as for general manufacturing and things like that, we x-ray artillery shells. I'm sure that a cannonball has gone through there at some point.
This is Bob Gilbert. I'm one of Patrick's colleagues. What we mostly do is not production rather, but R&D. But we have had some fun and games. The explosives ordnance guys every once in a while get a hold of something from display in some army base where somebody says, "Hey, how do we know that thing's inert?" And so, I don't know. It's always been inert, So they send it to those guys. They bring it up. So we've been able to X-ray some World War II, World War I, U.S. Civil War things like a 300-pound Parrott rifle slug. So we do sometimes get some nice historical stuff. I should probably talk to you about that, Jeff.
Absolutely.
Excellent.
We get calls quite often. What is this? Is it safe? So I go digging through the archives to see what tech data I can find and how it works. We have explosive ordnance disposal on post as well. But really is a team effort.
Well, we've been working with divers, trying to see if they can find our missing cannon. Somebody stole in 1980 a 1812 cannon from in front of the Steuben House. So we don't know whether they somehow dragged it over to the river. I mean, it could have been 1,400 pounds. So I don't know if we could get it to Picatinny or not, but it would be interesting to see, know more about it when we finally do get a hold of it. I'm not sure if we will. Like I said, all that time has passed, but I did start thinking about pursuing it when I read about the FBI getting involved with looking for somebody's artifacts that went missing about the same time frame. Turned out somebody was going around to different museums, this fellow, to steal things, and they got interested even in recent times. So I'm not sure what that would involve for our part, but so far it hasn't turned up anyway. What was the size of the cannon? You x-rayed a cannon? What size was it that you've done previously?
Well, the cannon that we did previously was, I'm 60 and I was probably a pup in high school when they did it. It was done on an old machine that was very good penetration, but not a lot of flux, a lot of energy. So they apparently, the anecdote we've got is they hung it in front of the thing and left it for the weekend, which, not something we do these days. But it was a ship's gun, so many pounds, theoretically an older gun. And the concern was that they thought maybe pirates had stuffed booty into the cannon, sealed it, and thrown it overboard right before they were captured in an effort to go back and get it. Again, that's all anecdotal. We can handle the weight. It would be a big question on the dimensions to see if we could penetrate something like that. But by all means, if you come up with something, please contact Jeff again, and we can certainly see what we can do for you.
Well, another object I was just thinking when talking, and maybe Jeff can add perspective too. It was a bar of pig iron it's a fragment, but it's about, like, I'd say 10 inches long, that has the initials LON on it, which Robert Erskine wrote about shipping to New Bridge by ox cart, wanting to get to the water for the easier transportation. And but if it was x-rayed, whether it would show more information about the value of the iron or the makeup of the iron, perhaps. I don't know much about iron, but would it have bubbles in it or other debris in it? Or
we could certainly do something like that. We could image it, but we also have several sister labs who could, depending on what you're willing to allow us to do, could do various other metallurgical tests. Ultrasonic, which is non-destructive, mag particle, which is non-destructive. So we could very possibly do something good for you that would give you some information that you could present with the item to your viewers.
And again, it's never been conserved either, so that's another project too.
Well, the good thing that you have something like that, it's going to be corroded on the outside, like you saw this barrel. But if it's a large chunk of material, the inside should be relatively unchanged from whenever it was constructed, poured, cast, whatever. So we can always take a look at it. If we come up with nothing, we come up with nothing, but we might be able to tell you something.
Mm-hmm.
Sounds good.
Oh, that's fruitful. All right. Well,
Yeah, we have a few Civil War era cannons on post if you ever want to try it out, Bob.
Yeah, I think some folks would get pretty sore at us if we started dragging cannons around.
Probably.
Yeah.
Well, all right.